Hello, fellow developers. Have you got an AKS Kubernetes cluster and have potential for your ports to be exhausted, aka port exhaustion? It's very easily done. Each node in a AKS Kubernetes cluster only has 1,024 ports by default, and each request has a timeout of 30 minutes. So if you're creating more than 1,024 requests in 30 minutes, in under 30 minutes, you could be hitting this problem. So we're going to have a look at that. In the meantime, do like and subscribe, and we'll have a look at and see how we can resolve this issue. So let's jump right in. We have this documentation over here around AKS, kind of explaining the situation around port exhaustion and how it can occur. If you scroll down here, there's some like even equations over here. Where did they go? Port exhaustion equation. Here we go. We've got an equation here that you can work out how many ports you have per node in your AKS cluster and how many you need, and you can pre-allocate some extra ones. So if we look at some of the documentation, the defaults are that if you have less than 50 nodes, you have 1,024 ports per node available. If you have more than that, the number of ports per node actually drops off quite significantly. So for example, if you have 52 nodes, you have 512 ports per node, and then that drops the more nodes you have. There's some examples here around how this works, but effectively what's happening is that each Kubernetes cluster, you get a standard load balancer, and the load balancer has a number of IP addresses associated with it. Now each IP address is given 64,000 ports, and if you have too many ports allocated per node, or not enough ports allocated per node, or you have a lot of nodes that are using up a lot of ports individually, that you can run into this port exhaustion problem. So let's take a look and see how we can solve that issue. If we look at our code itself, this is going back to our Kubernetes, our Pulumi infrastructure as code IaaS code, and so we're using Pulumi so that we can use C# code to bring up our AKS cluster, and this is an ongoing series. Do check the previous videos out, but in this particular episode, we're going to have a look at how we can reduce the chances of having your ports exhausted. So this is our managed cluster, our AKS cluster over here. The key thing over here to do is to set up a load balancer profile, and this is where we can configure how our load balancer is, how many IP addresses it has, for example, and there's a few settings in here that we can set. The first one we'll talk about really quick is idle timeout in minutes. So by default, each connection going out through the standard load balancer in an AKS cluster, for outbound connections this is, has a timeout of 30 minutes, which is a really, really long timeout. So if you're creating more than 1,024 connections during that 30 minutes, you're going to hit port exhaustion. One way around this is to reduce the idle timeout. So for a standard load balancer, the actual default timeout is 4 minutes, but in AKS, they've increased it to 30, just in case you want to do some long running connections. So I think, just want this to be configurable. So it's up to the owner of the cluster to be able to configure it. So that's what I'm going to do. And if you set up a Pulumi cluster, if you've watched our previous episodes, you know that we can use this YAML over here to configure our cluster. We're just going to create a new a load balancer section over here, balancer, and we'll call this setting idle timeout in minutes, and we'll default to 4 minutes for our development and production clusters. Oh, I forgot to update this one. So we'll default to 4 minutes, and we'll add some more settings here in a minute. To pick up these settings, we'll have to create a new configuration class and add it to our Kubernetes cluster. So let's we'll call this Kubernetes cluster load balancer. Add class. It's thinking about it. Kubernetes cluster load balancer, and we will make it public. Not sure why there was not a space there. That was strange. And this is going to have our idle timeout in minutes property, and which is just an integer. And what am I doing here? I just want to set it to a default value, and we'll need a property on our Kubernetes cluster configuration. So this represents this section here in the YAML. So we just need to add the load balancer property to it. So I'm just going to do that now, and we'll just say public load balancer and add that. And maybe if we add some comments to this, gets or sets the cluster load balancer settings options is a better word. Let's use that, and we'll go over here and add some validation to this as well. So we'll need to create a validator for this, and I'm just using Fluent Validation. If you haven't used Fluent Validation before, I have done a video on using it, so do check that out. Validator. Why is this space not being introduced there? That's very strange. And this, I think, if I remember correctly, we're just inheriting from abstract validator. And in this case, we want our we just want to create a constructor here now, and we want to create a rule x dot idle timeout in minutes, and we want to make sure it's inclusive between 4 minutes and 120 minutes. Those are the minimum and maximum values allowed. And we also want to apply this validator. So we'll go back to our Kubernetes cluster validator, which validates the Kubernetes cluster section, and we'll include this validator here. So we'll do this dot rule for x dot load balancer dot set validator. Oh, can I do that? Can I use a generic type here, or do I have to new up one? I can't remember. I have to new up one. Okay. So that's our validator set, and we can now move on. So we've got our setting. We should just apply that in our Kubernetes resource. So we have a configuration object that we're just passing into the constructor for this. This is a component resource. It's a custom Pulumi resource that we've created, and I'm passing in the iConfiguration object, which just represents the configuration here in this YAML file, and we're just going to plug that in configuration.kubernetes.loadbalancer.idle timeout in minutes, and we're done there. So we'll default to 4 minutes, just because that's what the standard load balancer does by default. And I think it makes more sense. It can be a problem if you're gonna, if you're going to create long running requests, that could be an issue. So just watch out for that. Next thing we'll do is should we just deploy this really quick? Add idle load balancer idle timeout. So we'll just wait for that to build and get deployed. So Ajmal is asking, what does port exhaustion mean? So port exhaustion, so each virtual machine has a certain number of ports. Even the machine that I'm running has a certain limited number of ports. I don't know what the exact number is for a Windows box. But once you use up all of those ports by opening connections on them, you're gonna run into port exhaustion, and that just means you've run out of open ports. And this can happen in a Kubernetes cluster also, but just because in a Kubernetes cluster the default is 1024 ports per node, and that's a very small number of ports, given that on my Windows box I have tens of thousands of ports. So it's something to watch out for. It's just a bad default in Kubernetes, in Azure AKS, I think. I'm not sure if it's also the default in other cloud vendors, but I think it's something, if you just pre-configure your AKS cluster, you can get some better defaults as we are doing here. So so the idle timer is just saying, you know, on this connection on an individual port, we want to time out the connection quicker than after a certain number of minutes, just so that we can retrieve that port and bring it back to the unused pool of ports quicker. If you have a really long timeout, that port is going to be out of action for, you know, however long you've set it to. So that's our idle timeout. Let's talk about the other settings over here now. So we do have a way you can determine the number of ports per node, and the way you do that is so there's a kind of a formula here. So you have 64,000 ports per IP address on the load balancer, and you can increase the number of IP addresses on each load balancer. So you can double this. If you have 2 ports per load balancer, this would double to 128,000 ports in total for your cluster. We have the number of outbound ports per node, and that's something that's configurable. We have the number of outbound IP addresses, and we have the number of nodes in a cluster. So we know all of these things, and we can do some calculations to figure out how we can increase the number of ports that each node has. So let's take a look at that next. So we'll look at so the first setting we'll look at is allocated outbound ports. So this is just the default is 0. If you set this to default, to the default of 0, it just does the default behavior that I've already described, where it gives 1024 ports per node. If you define anything else like 1 or whatever, 1024 or whatever, it will change the default, and it will require you to set up a few things here, which I'll show you in a second. So you can set this between 0 and 64,000 for each load balancer, for each VM, sorry. And we'll configure this from our YAML file in a second. The other thing you can set up is the managed outbound IPs. So we'll just new up one of these things, and we'll just move this setting up, and this, where you can set the count of the number of IP addresses. So this is IPv4 addresses on the outbound connection. So we need to set this to something. So this just says how many IP addresses are we going to have for our load balancer. So as I said earlier, if you only have one, that's a maximum of 64,000 ports, according to this calculation over here. So we need to basically calculate this number based on the number of nodes we have, the number of ports we have as well. And the number of nodes we have can change. So if you have 10 nodes, say, but during an upgrade, you could have 20 nodes, just because it's going to bring up another 10 nodes with a new version of Linux, or new updates to Linux or the Kubernetes pods, and then it will take down the old version and then replace that. So potentially the number of nodes could be double, and we'll look at that as well. I wrote a quick calculation here, which I'm just going to copy and paste over here above this cluster. So the number of ports per IP, 64,000. That's our constant. I'm just going to move that up here as a constant. And then we need to work out the total node count possible. So this is the total number of nodes that is possible. And for now, I'm just going to use the maximum node count. So for each node pool, what is the maximum number of nodes we've configured? So if we go back to our node pools, we have a system node pool, which has one node count, maximum node of 1. And this is user node pool that has 1, and a spot node pool that has 3. So 3 plus 1 plus 1 is 5. So we'll have 5 nodes in our cluster. So that will be 5. And then the number of ports we want per node, we can pass that in over here. And then we need to do the calculation. So this is saying the total number of nodes possible divided by the 64,000 ports per IP divided by the ports per node of 1024, and that gives us the number of IP addresses we need for our load balancer. We can plug that in right there. Now we need to retrieve some of this from configuration. So let's do that next. So we'll go back over here and we'll say we want to set up the number of ports per node, and we'll default that to 1024 for now. And we also and I think that's it actually. So this is going to get calculated, and this is going to get calculated as well based on the other settings in our cluster. So we just need to pull this information out, ports per node, and we'll go back to our load balancer configuration. And we'll say get set equals default. So that's our ports per node, and we also need some validation for this. So just in case you put the wrong value in your in the YAML, and I believe the allowed values are 0 to 64,000. So I'm just going to use an underscore here for the number separator for the 1000 separator. That makes it look a bit nicer. I guess if you set 0 here, 0 ports per node, you're basically turning off all outbound connections, all outbound requests in your cluster, which would be quite a strange thing to do, but it's possible. So now that we have that set up, I will change this ports per node, and we'll retrieve that from configuration. ration.kubernetes.load-balancer.ports per node. So now that we have that, and we also have to set the ports per node here. In our allocated outbound ports setting. So now that we have our load balancer configured and our outbound IP count, we need to take another look at the total node count possible. So far I've just taken the maximum node count, but like we said earlier, I have set here a value, a maximum surge of 33%. So what can happen is, if I had, say, 3 maximum nodes in, let's do the user node pool. If I had 3 maximum nodes here in my user node pool, then during an update of my cluster, it will bring up 4 nodes. It will bring up 1 extra node. It will update that. That will be a new version, and then it will take down 1 node. So at any one time, you will have 4 nodes in the cluster. So we need to take that into consideration. And I wrote a bit of code to do that. So if I go back to my node pool, so my node pool has this maximum surge value, and it can actually be a percentage or a number. So you can either say, I want to bring up a maximum surge of 3. So that will say, update all 3. When you're doing an update, bring up 3 extra nodes. So you'll have 3 plus 3 equals 6 nodes at any one time. And then eventually 3 will go away and you'll end up with 3 again left over. Alternatively, you can do this as a percentage, as I've done. And I think it makes more sense to do it as a percentage because it's just easier to work out. Like if I increase this number to like 30 nodes, if this was still 3, it would do 3 at a time. If this was 33%, it will do 10 at a time, which I think makes more sense with the percentage. So as long as I set the percentage, I don't need to update this maximum surge anymore. I just need to update this number over here. So I'll just change that back. Go back to my node pool and add this property over here. So what this is saying is, what's the maximum node count possible in this node pool? And if the maximum surge ends with a % sign, meaning it's a percentage, we parse the maximum surge percentage over here, and then we do a quick calculation to say what's the maximum surge count, what's the count of the number of extra nodes which will appear during an upgrade, and then we just add that to the maximum node count. And then if it's a number, we just parse that maximum surge value instead and set that over here. Maybe this can be improved slightly. So maybe I can maybe we can work out the maximum surge value here. So int maximum. I've got a bit of duplication here in the code. So that last line was duplicated. Maybe I can just do that and then return maximum surge over here like that. So we've got one less line of duplication, although there's this extra line over here that's kind of hanging around. So now that we have this, we can plug that in here, and now that should always work during an upgrade even. So this is the total node count possible. That should now work. Let's give it a go. So so it turns out we got an error there when we set the idle timeout, and it turns out the error is saying you must specify the managed outbound IPs, outbound IP prefixes, and outbound IPs. So basically you have to set up the other things that we just did to get this to work. So we'll set the load balancer options and try and deploy again this time. So the options we've set, just to review, are we're going to do 1024 ports per node and 4 minutes idle timeout. And that should get deployed. In the meantime, we will really quickly discuss some more to this story. So it gets more complicated because Azure AKS has this new preview feature called the managed NAT gateway, and it's in preview, so you can't quite use it just yet. But what this is saying is, instead of using the Azure standard load balancer for all your outbound connections from your cluster, you can use a NAT gateway instead, and that stops some of the need for all of this calculation stuff that we're doing, and works in a slightly different way. So here it's just saying when you're using the standard Azure load balancer, there's some limitations on the amount of outbound flows of traffic that is possible, and we've seen how to overcome that. But using an Azure NAT gateway, it also allows 64,000 outbound flows or connections per IP address, and it allows a maximum of 16 IP addresses. So there's a kind of a limitation there as well. I'm not actually certain what the maximum number of IP addresses allowed in the node in this load balancer is. That doesn't really say in this documentation. So the way you use this, as far as I can work out, is, oh, hold on, we've got a problem. Managed outbound IPs dot count is too low. Oh, okay. So it looks like we need to set a minimum here. So outbound IP account, we need to set a minimum of 1. So we can do math.min 1 outbound IP count. Maybe we can just stick this calculation in here. And it would be nice to log this somehow, so we can say what's going on. So Pulumi has this log function over here, and we'll just log some of the settings over here. So we'll say idle timeout in minutes. We won't log that because that's not calculated. We'll say nodes node possible. We want to say our ports per node. Ports per node, and we want to say what's our outbound IP count. Outbound IP. Oops. IPs. That auto correction was not quite right. If you haven't noticed already, I think I'm using the new GitHub. Where is it gone? GitHub GitHub Copilot. Oh, I don't have it installed on here. I have it installed on my other preview version. But Visual Studio already kind of does give you suggestions like GitHub Copilot, so I'm not sure what the difference is there. Anyway, what is this? Oh, private. We'll add a private there just to keep our linting happy. So we can deploy that again, and hopefully we shouldn't have that problem where the managed IP count is actually less than 1, i.e. 0. So that while that's deploying, let's go back to looking at the managed NAT gateway. So there is some settings over here that you can set instead of this load balancer profile stuff. And what you can do is, instead of setting all of these settings, you can set up, I don't want to, while it's deploying, change the code because it is building it right now. We'll give it just a second to build, and once it's built, it will deploy a binary. So from a binary, so we can change the code while it's actually doing the Azure deployment. So it kind of tells you what it's doing here. Restoring the project. It's probably building it now actually. It does take a moment. Oh, .NET build completed successfully. And it should now quieten down on the CPU. Oh. 5 nodes possible, 1024 ports per node, 0 outbound IPs. What's going on here? Didn't I set a minimum? Oh, I want a maximum, don't I? Maximum. Max. Is that right? So yes. Yes, I want a maximum. That's the wrong way around. I had that. That was silly of me. We'll try that one more time. And we'll just commit this code as well. So we'll say this is add protection against add load balancer options. Commit that. And push that as well. If you're looking for the code is in the description below, so do have a look at that. It's all available on GitHub. So this whole project is creating a Kubernetes cluster. It's creating a virtual network where the Kubernetes cluster lives, and various other bits and bobs that it needs. And we're trying to create a productionized Kubernetes cluster here, so trying to build it as best we can, make it as configurable as possible using this kind of simple configuration. We've got our maintenance schedule here when we want when we want Azure to update it. What's our SKU? I'm just using the free SKU here just because this is a development deployment, and we want the upgrade channel to be stable. We don't want the latest hot bits from Azure. We've got our load balancer settings now, and our node pool settings. So we've actually got 3 node pools configured. One of type system, where our Kubernetes pods, system pods actually run in the system namespace. And we've got our user node pool, where basically your applications can run, and spot node pool, where you can have kind of on-demand batch jobs running for a cheaper price whenever Azure has spot virtual machines available. So it's deploying now. This time it says the output FQDN is going to change. And while that's happening, we can go and change some of the code now. So we'll just comment out some of this for a moment. KC, control KC, control K. Not able to edit it for some reason. That's strange. What? I can type, but I can't undo. Whoops. Very weird behavior going on. Let's try opening that file again. Oh, I've lost my changes and I still can't edit. Can't delete. Visual Studio is doing some strange things at the moment. We might have to restart VS. It says there's a change to this file. Maybe that's something to do with it. Okay. Let's see what happens now. Okay, that went back to normal, I think. Okay, so the settings for the NAT gateway are as follows. So first of all, you have to tell it you want to use a managed NAT gateway, which is the preview feature, as opposed to the load balancer for the outbound connections. And once you've done that, there's this NAT gateway profile setting. Have I got this in the right place? I haven't. I should have not commented out that section, but commented out this whole section over here. And oh, that was weird. Okay, there we go. So then instead of a load balancer profile, you give it a NAT gateway profile. And similarly, you can specify an idle timeout. So I'm just going to plug in the idle timeout there in minutes from our configuration. And you can also specify the number of IP addresses you want. And I guess that's the outbound IP count. There is a kind of a discussion on GitHub around this managed NAT gateway. Like, I'm not sure what the major advantage is of using this, as opposed to what we did with our load balancer and all the code where we kind of calculated the number of IP addresses we need. There is a discussion on the Azure AKS GitHub. It's 1122. I'll stick that in the chat. And a lot of people are going into why they want to use a NAT gateway, but my personal question at the end was, what's the recommended approach for a productionized cluster? Let's see what they say. We may change over to using this. As I say, it is in preview at the moment, so I just wouldn't use it just yet. And one other thing you can do here is you can actually specify, whoops, I think it's effective outbound IPs. No, I think it was this setting. Let's find out. Yes. So you can actually set up a NAT gateway elsewhere and refer to it by ID here, and just point to it. So that will give you full control over all of the NAT gateway settings that you'd like to set. So that's giving you ultimate control over there. I think one of the major advantages of using a NAT gateway is that you can predetermine the IP addresses that are used for your outbound connections. So if you have some particular requirement around having particular IP addresses that you want used in this scenario, then you can do that. So for now, I'm just going to comment this out and write a quick comment saying managed NAT gateways can, so we'll put in a link here, can be used as an alternative to load balancer to a load balancer for outbound connections. For now, I'm just going to comment out this code because it's in preview and I'm not really certain what benefits are at this stage. So we'll go back to our code over here and use the standard load balancer profile. If we go over here, we've got our outbound connection all sorted out. We've got one outbound IP address, 5 nodes possible, 1024 ports per node, one outbound IP. I think I'll just format that slightly better. In this, well, maybe we'll do some new lines over here, /r/n. So maybe we'll say the maximum possible, including surge, this many ports per node, and we'll do a new line here as well, 5 outbound IPs, outbound load balancer IPs, and we'll just put a full stop there. Cool. We can run that and just make sure it produces better logging. And cool. We'll just commit that. Add better logging for load balancer info. And I'll push that out so it's available to you. Do like and subscribe. It helps the channel out, and I'll see you in the next one.